We're going to look at how we can manipulate surds, but perhaps the first thing we may ask is, well, what is a surd? And I think this is best illustrated by demonstration. If I take the root of 4, I'll find it evaluates to be 2, which is a rational number. If I attempt to evaluate the root of 2, then I can't, because I end up with an irrational number. The best I can do is write out an approximation, and what I get is a decimal number that goes on forever and doesn't repeat. If I evaluate the root of 9, I'll get the rational number 3. And if I attempt to evaluate the root of 10, again, I can't, because it's irrational. And the best I can do is write out a decimal approximation that goes on forever and doesn't repeat. When you can't evaluate the root here and we get an irrational number, then it's a surd. And here we have the two rules for manipulating surds, and both of these rules are very straightforward. In fact, a lot of the skill is in getting your expression into a form where you can use the rules, and I'll explain what I mean using this example. You may be asked to simplify this surd, the root of 12. However, neither of the rules apply. But if you see that actually 12 can be written as 3 times 4, you've then got yourself into a position where you can use rule 1. And the advantage now is that I can evaluate the root of 4. And by convention we'll tend to put the number in front of the root. Now you may ask, why didn't I pick 2 times 6? And the reason is I was looking ahead and realizing the root of 2 and the root of 6 were both surds themselves and couldn't be evaluated, but I realized that the root of 4 isn't a surd. I can evaluate it. So really, when you're looking at simplifying an expression like this, you're always looking to see, is one of the factors a square number? You're always looking for the square number that you will be able to evaluate, such as 4, 9, 16, 25 and so on. And again, the second rule is quite straightforward. Instead of writing it out like this, I can write it out as 2 separate terms. And again, the advantage is that this denominator isn't a surd. It can be evaluated. Because the root of 16 is 4. I'll look at the second rule, and again, as I've said, these rules are simple, but it's all about setting yourself up so that you can exploit the rules. And again, I'll show you a slightly different technique using this example. And just as in the first example that I showed you, I'm not in a position at this point to use either of the rules. However, again, if I write this out in a slightly different way, now I can use the second rule, and all I've done is written 2 out in a different way as the root of 4. therefore allowing me to use this second rule. And of course 20 divided by 4 is just 5. So I hope this emphasises the fact that the rules are straightforward, but you've got to be looking for ways in which you can set yourself up to use the rules.